In this video, we're going to see how does the circumference of a circle compare to the diameter of the circle. To do this activity, we're going to need a ruler, a tape measure, and several cylindrical objects such as cans or jars. I'm going to use the ruler to find the diameter of the can, and since we know it's the longest chord, we'll just keep moving it until we find the largest length, which on here is about 8.5 centimeters. Okay, then we use the tape measure to measure the circumference of the same object. Measure around. It's nice to have them small enough that students can hold it in their hand, and I see here that my circumference is about 27 centimeters. Okay, I'm going to record that, and I'm going to measure all of the objects, and I'll share my data table with you in just a moment. Here is my data table for the 5 objects that I measured. What I also did is I took the circumference and I divided it by the diameter, and then I got an average for the 5 objects. What I want to do next is to graph my data, but in order to graph it I have to decide which is my independent and which is my dependent variable. So I realized that the circumference depends on the diameter. So when I graph it, I'm going to put my diameter as the independent variable on the x-axis and my circumference as the dependent variable along the y-axis. Since my graph will be representing the measurements of real objects, they'll be positive. So I'm just going to be graphing in the first quadrant. I plotted my points, and I can see that they appear to be following a straight line. So I'm going to draw in the trend line, and I'm going to draw it in through the point 0, 0, through the origin, because I know when the diameter is 0, the circumference will be 0. So I'm going to use a ruler, and I'm going to draw it in. Here is the graph showing my trend line going through the point 0, 0, and it does in fact touch, or is very close to most of the points on the line. What I want to do now is to find the slope of the line, which will represent the average between the points. In order to find the slope, I'm going to look for where the line will cross on the graph at the crosshairs. So I'll have my values will be integers. So I see here's a point. So I'm going to look at this one and right here. So I see I go up 1, 2, 3 and over 1. So my slope of my line is about 3 over 1. So that's my slope. And how does that compare to the average that I got on my data table, which was 3.188? It's very, very close. Now what I'm going to do next is I want to see what I get when I enter these points through the calculator, to see what the calculator will give me for the equation of the line through those points, through my data points. So I'm going to enter the points into the calculator. You can use whatever calculator you want, and I'm going to see what I get for a correlation and my linear regression. When I entered my data into the calculator and looked for the linear regression, this is what I got. I got that A, the coefficient in front of the x term is 3.115, or I'll just round it off to 3.12. B is 0.47, and I get my R, or correlation coefficient, to be 0.9999. So it's a very, very strong correlation. But what does it mean? What does the meaning of the A is the slope of the line. So on the calculator it gave me 3.12. On my graph it's 3, and on my data table it was 3.19, an average. So that's, the slope is saying for every 1 unit increase in the diameter, my circumference is going to increase approximately the 3.14. That's what the value of pi is, approximately what we came up with. And then on the equation, the value for B, well, we know that it should be 0. If I don't have a diameter, I shouldn't have a circumference. But given B, which is the y-intercept, says if I don't have a diameter, my y-intercept or my circumference is 0.47. Still, it's small, but we know that doesn't really make sense. So that's our error. That's what it represents, the error or inaccuracies in our measurements. And so that's, we can see in several different ways how we come up with an approximation for pi. We did it point-wise in our data table. We did it with the slope of the line of best fit, or the trend line on our graph, and we also did it using the calculator. And each way we got slightly different answers because of how they're calculated, but we're still real close to the accepted value of pi. Thank you. And this concludes our activity.